Here we have the MIC7401 EV board. Now, as you can see, the device is quite small for being $5 and a boost. Let me compare that to a dime. This is a US 10 cents currency. As you can see, the solution is smaller than the dime. Now, in this layout, we actually have the inductors behind the board. So let me show that to you. So in the top, this is the bottom side of the EV board. Well, let me actually show this here. As you can see, let me zoom in a little bit. You can see that the inductors are on the bottom, but overall the solution size is very small, 8.43 millimeters by 12.154 millimeters. So now here's the EV kit being powered by a 5-volt source. This is your V-in. And now we're looking at a fluke meter, so we can see what the output voltage is. So right now we're looking at channel 1, which is 1.8. Now this has the default settings from the MIC7400 data sheet. So the settings are 1.8, 1.1, 1.8, 1.05, 1.25, and 12 volts. So let's see. So right now channel 1 is 1.8. Let's move this to channel 2. There we go, 1.1. Let's go to channel 3. 1.8, channel 4, it should be 1.05, we're pretty close. Channel 5 is 1.25, and then 12 volts should be our channel 6, which is a boost. And there you have it. Now, these output voltages can be configured to be whatever output voltage, as well as sequencing and soft start. You know, it can be all pre-programmed because we have EEPROM inside our device. So all you need is a dongle that comes with this EV kit that connects to this EV board through a USB port. Now, we're not going to talk about how to download the software or the EV kit. That'll be a separate video. But I want to show you how it works, since I'm more interested in actually showing you it working than actually downloading software. So the dongle connects, this is your ground pin, it connects to that ground pin. Make sure that you do have it flipped over, which I have it here. Now I'm going to show you the GUI. So this is how the GUI looks like. Let me just zoom here to my laptop. Let me focus here. Now I apologize, you do see the refresh rate, so I'm going to just take a screenshot as soon as I get to focus here. Yeah, I'm just going to take a screenshot. I think it'll be easier to see than working from the video. Okay, so right now we're looking at channel 1 of this MIC7401. And with the GUI, actually I can increase the output voltage, as you can see there, by just moving the register or the GUI interface, or actually lower it down to, let's see, the lowest setting here is 0.8 volts. So now I don't have a load, so this is going to slowly decay down to 0.8, or else this will be done much faster. But this is all adjustable, and then I'm going to show you the GUI actually how it looks like from my actual screen. But I just want to see that all this stuff is programmable, and all this the settings could be programmed right to EEPROM. So when you turn on and turn off the device, then all these settings that you want for your application will be saved on the EEPROM, and it'll be available to you as soon as you start up. Okay, here we have the 7401 tied to a scope, so we can see the output voltages. Let me zoom in here to the output to the scope so we can see what we're looking at. Let me get a little closer. So now we're looking at the channel 1, channel 2, and channel 3 and channel 4 of the MIC7401. As we can see, channel 1 is 1.8, channel 2 is 1.1, channel 3 is 1.8, and channel 4 is 1.05, just like before. But now we're going to talk about the sequencing now. So the way to do this, I'm going to go single sequence. I'm going to turn the power off, and we should be able to capture. There we go. So now we're looking at channel 4 starting, and then the next channel, channel 2, channel 3, and then channel 1. So this is the default settings. Now these are all configurable. So by using the GUI, I'm actually going to change the sequence, okay? And while I'm doing that, I'm also gonna, well, let's just change the sequence. So I'm gonna make channel 1, channel 2, channel 3, channel 4 go on, as well as channel 5. We can't see channel 5 or 6 on this scope because there's only a 4-channel scope. But let's go through that experiment. Okay. Okay, so now what we've done on the GUI is we changed the power sequencing. So channel 1, channel 2, channel 3, channel 4 are going to go consecutively. We also changed the output voltage just to be a little bit more differentiating on the scope. So we got 2.5 for channel 1, 1.8 for channel 2, 1.25 for channel 3, and then 1 volt for channel 4. And then we disabled the boost. So now let's take a look at the sequencing to see if we were successful. So what we're going to do is going to turn power down. We're going to put single shot, and then which is going to power up, and there you go. As you can see, we got channel 1, channel 2, channel 3, and channel 4. And since I did it so it's easy to see, you got your 2.5, 1.8, 1.25, and 1 volt, and now you got the sequencing. And we also disabled the boost. So if let me show you that as well. So here we can see that the boost is disabled. Now remember, there's no load, so it's so the voltage is slowly decaying. But if we wanted to enable the boost through the GUI, you're going to see that the volt goes back to 12 volts. And once again, I could disable the boost as well, and you can see that the voltage starts to trickle down as there's no load. So, but that's just to show that even we can program all that on EEPROM. If you don't need a channel, you can disable it. Okay, so next step is let's look at let's do some of the soft start experiment. Okay, we're looking back at the scope again, and obviously the output voltages are all the same thing. Now what we've done is we changed the soft start for channel 1 and channel 4. Now for channel 1, we increased it to 1.8 microseconds, and for channel 4, we did half of that, which is 64 microseconds, so you can see the difference. So let's go look at let's power down. Let's go to a single shot, and let's turn on so you can see that. And now you can see. Maybe I can turn this a little bit. Well, I guess you can see now that the soft start is much slower in channel 1, and the soft start is a little faster in channel 2, and the other ones are pretty straight up. So all this is configurable to match the performance of the design, to get the performance out of the customer, what the customer wants for their application. Another feature that's available in the GUI is the pull down. So if you, for example, want to increase the decay the voltage output really quickly, for example, I'm adding pull down on the GUI, and I'm going to disable channel 1, and and you're going to see how that compares without the pull down. So that's with the pull down. Now we're going to turn it on, and we're going to disable the pull down, and then when you see me turn it off, it's going to slowly decay. So for some applications that you need a faster response to turn off the power, then you do have the ability to pull down the power, or you have the ability to let it float down. That way it could slowly turn off. So, and there you go. Okay, now let's look back to the boost. Remember, we disabled it. Now we're going to turn it on again. Let me just make sure that I'm connected here. Okay. So now we can turn it on, and then now we're going to pull the pull down, and you can see how quickly it turns off. I'm going to turn it on. Now we're going to take off the pull down on the 12 volt supply, and then you can see that it goes quite slowly. And let's help it out by pulling it down so you can quickly get down to 0. Turn it on, and then go back to and then turn it off. Okay, so one more demonstration to show you also what you can do in regards to the power sequence. Now in this case, what we're going to do is we're going to increase the sequencing by 3 milliseconds compared to the 1 millisecond that we originally had. So let's go check this out. So let's power off. Let's put single sequence, and then we're going to try that. So now you can see that the delay has increased by 3 times between each channel. Compared to the previous demonstration. And if you look at the GUI, you can increase the startup sequence up to 7 milliseconds. Now I didn't do that because you won't be able to see all channels on the scope without me changing the time scale. Okay, so now we're going to do the short circuit test. Now this is why people don't let marketing in the lab, because we want to do anything here. So we're going to short channel 1. So what I'm going to do is I'm going to take the ground from channel 1, just make sure that's the right one, and I'm going to take channel 1, the outputs. Now you're going to see that on the scope as I short circuit. So now that's the short circuit protection. Now if I remove the short circuit, this device is completely shut down. So now, as you notice, the other channels were not affected by the short circuit, and the reason why is because they're actually 5 individual analog bucks with a digital wrapper. So now the way maybe to turn this on, we're going to see if we can enable it and disable the device, or let's just do the power sequence. And as you can see, channel 1 is back up again because short circuit protected the device. Okay, so now we're looking at the GUI, and I'm going to go through that demonstration again when I'm going to short channel 1. So now we're actually in, as you can see that I'm in direct in editing mode. So now I can actually talk through the I2C dynamically and make the changes. So the only thing is when you do the short, which I shorted just now, you still got to do the read, because it's not like giving you like, so let me go to registers, let me read. And then as you can see, now we went to overcurrent, right? So it's flagging that it's overcurrent since I just did the short. So now what I'm going to do is I'm going to power off the device. I'm going to turn it on again. So now the channel 1 is up and running. And when I do the read again, I'll go back to power good. So that's the information that through the I2C you can also read back into either your microcontroller processor to do some of the housekeeping stuff that you might need for your application. Okay, let's do one more demonstration on the short circuit. So what we're going to do is we're going to short circuit channel number 1, short circuit channel number 2, short circuit channel number 3, and why not, let's do number 4. So now as you can see that all the channels have turned off. Now with the GUI, I'm just going to turn it off and turn it on, and you can see channel 1 turning on. Let's do number 2 turning again on. Channel number 3 and channel number 4. So with the I2C interface, if you were to go into current overcurrent shutdown, you can actually restart it just dynamically through the I2C.